So this is currently my hookup to my layout, and power hookups. What I have here is one of these goes to a programming track, and then the other four go to various feeds for the track so that I can isolate into different power districts. The other thing I've done is, if you look at these two, one's a programming track, one's a regular track, and they both feed up here to this double pole, double throw switch here. So if I throw it in the one direction, this is a programming track from here up to right there where there's a gap. And if I throw it the other direction, then it's power. And if I just leave it in that position there, in the neutral position, then there's nothing on it at all. So it's really easy for me to swap back and forth between having power to the track or just doing a programming track. Now, in order to control this, I have a Digitrack system. Digitrack system looks like this. So this is a Super Chief 5-watt booster, power supply. This plugs into the wall and then it powers this guy, which is the power supply, and then it provides power to both my wireless unit, and I believe that's a BDL 168. It in turn powers these 1, 2, 3, 4 power, plus you can see that here I just have my programming track coming in. So it's really easy for me to swap layouts and stuff. I just go ahead, I select one of the 4 to the right for power, and now in this case that plugs into my test track. And if I decide I wanted to run my test track on DC instead and plug it from here, I go ahead and bring in my transformer. My transformer has just this plug on the end, and then I turn around and with one hand, because I'm recording with the other, plug it in, and now I can run DC on my layout. Of course, I can do that on the other one as well, although because I've got 4 different power districts, I can only power one district at a time, unless I make up a different plug here, which I may do at some point in the future. Now, what that means is if I get another unit like the ECOS one that I've been experimenting with, I have to set up this kind, it has to be the female one, and plug it into the ECOS. And that means I have to make one of those cords up, which isn't a big deal, but and I'll show you how I end up doing that, as I had to do for the ECOS system that I have. So on the ECOS system, which isn't plugged in currently, I have 2 cables. The short one is for the programming track. I need to label it so I don't forget. And the longer one is for power. And I've just soldered up those cables so I can use them. As I get other units, I'll just do the same thing. This makes it entirely portable to whichever of my layouts that I want. As I create a new layout, I'll be able to just move the power supply over to that one. Alright, what I explained before is, here's the before picture. So I have this connector, I have a couple of pairs of wires, I have a red one and a black one, and then I have what I'm going to connect it all to. The end product looks like this, and I thought I was recording it last time, but it turns out I wasn't. I am just using automotive wire. It is 16 gauge, which is a little thick for this guy. When you look at it, there's a tiny hole there, and 16 gauge wire won't fit through that, so I'll show you what I do to get around that. But I prefer to have thicker wire as I'm doing this. Then I know I'm not going to have any kind of current loss whatsoever. So step 1 is to strip the wire, and I don't need too much stripped off, so we'll take about that much, and I'll do a test fitting to make sure that looks okay. For the black wire, it is going to just go here, and so that's a little longer than I need, which means I'll come in with my trusty cutters here. Well, I won't cut it off yet, I'm going to wait till I tin it. And in this case, similar kind of thing, this is going to go in here, but that's way too long. It needs to butt right up against there. So I'll tin these first, and then I'll trim them afterwards. To tin them, I'll bring in this guy, which is going to make it a little, well, I'll try doing it sideways. In each case I have, can't remember what these are called. There is a name for them. These are, I use them as a soft vise. I don't want to mar the insulation, so I wrap a little piece of cardboard and then I put the alligator clip on. That way it is still held firmly, but I don't have an issue of potentially, you know, marring the insulation at all. I need a little bit of flux, put it on there. A little bit of flux, put it on there. And then double check and make sure you can see what I'm doing. Can you see? Yeah, you can see to that point. Okay. Get my solder ready. Get my glasses down. Get in here. Flux melts. Solder starts to melt. Make sure we get all the way back to the insulation here on both top and bottom. And being a heavier gauge wire, needs to make sure that it's heated up well so that the tinning goes all the way through. I'm using stranded because this wire is potentially going to be bent lots, so I want to make sure. I'll go over to the black piece. I mean, I'm an old DC guy. I just pretend not to be. And for that, of course, red is positive, black is negative. But with DCC it doesn't matter. Okay, so I'm going to make sure, okay, everything's well tinned now. Clean off the tip, throw that back. And immediately grab the wire and fry your fingers. That's part of what you have to do, I think. But we'll grab this one. Should be okay now. Yep. Do a test fit here. And in the test fit, it's in okay, but it's way too long. So we'll grab any old pair of pliers I have, with a cutter on it, cut a hunk off, check the fit again, and I can feel how that goes in just fine. I can see it's in as far as it can go, and it's flush against the insulation, so I did good on that one. On the black one, get this off. It's going to rest right along the bottom here. That's far. I only want it in about that far, so we'll cut a little bit off of that. Now the other thing I learned is if I only tin the one end and then do the others later, I can make sure there's the same identical length after I've done this fidgeting. So that's better. The other thing I'm going to do is bring in my heavy pliers, and I'm going to squish this down now that it's been tinned. It'll let me do that. So I end up with a flattened instead of round wire. And came apart a little bit there, just put that back together again. Okay, so now when I put this on, it'll sit better. And I'm going to start to form this here, which is the strain relief, so that this will fit on like that. Next thing I'm going to do is get a little bit of flux in here, because pretty soon, if I do everything properly, there, a little bit of flux on. Maybe we'll zoom in a little bit here. Might be able to see a little bit better. So that this goes in there. And that's going to go down. Yep, can still get it in. Let's get it down a little bit more. What I'm trying to do here is get it down enough so it kind of holds it just like that. Then I can get it down the rest of the way. Hold it firmer. Then bend the other piece over. Get it in place. Then squish it down. Make sure it's not too wide. Squish it all together. And the only way I can solder this is to get this into my grips here. And now that it's in there, should be able to see enough. I need to drop my headpiece on here so I can see it well enough. Now, because it's already tinned, solder will start to flow pretty quick. Here it sizzle. Touch some solder in there. You can see it boiling. Touch more solder into there. I want a great joint here because this is also, as I indicated, stress relief. So I want to make sure that I have more than enough solder in here and people can yank the hell out of this. Well, I don't expect to, but you never know. Okay, so solder's now flowed everywhere it's going to flow. And now that whole thing's pretty warm, so got to give it a couple of minutes or seconds, I guess, to cool off a little bit. I'm going to put some flux on the end of this. And I'm going to stick it in the hole. It should melt pretty much right away because this is all warm. Yeah, that's still pretty warm. Okay, I'm just going to take this out so I can look at it closer. Oh, there we go. Okay, so that's now, yeah, it's all in great now that I went ahead and pulled it out. Okay, let's get this back in here. Let's push this back in. Remember, it's tinned, so yeah, it doesn't hold all that well, and the wires are enough. Okay, so first off, just gonna try and melt that enough. Grab some solder. Push the wire in a bit more. Hold it. So I can feel the wire getting warmer and warmer and warmer and warmer. Okay, it's getting too hot for me to hold now. So we'll just let that be what it is. Now, that's probably good, but I don't like to take chances. So what I end up doing is I grab some electrician tape and I'm going to wrap it around in there. But before I do that, wait for it to cool off just a little bit. I'm just going to grab a piece of paper towel. I can now grab this. I don't need it anymore, well, for now anyway. Move that out of the way. And I'll just slide this in, making sure I clean any residue out. There's a little bit in there, and so this will get that out. So next thing is to cut off a little bit of electrical tape. Don't need a lot. I come from an era where there was no such thing as shrink wrap, so yeah, I use shrink wrap sometimes, but not a heck of a lot. So that's all the way in there. It goes around the negative terminal. Okay, then I put the two together, and then I bring it back around all the way and just do a couple of wraps. So now what I end up with is something that's really strong, and the only thing that I have to remember to do before I do anything to these ends is put them through so I can get this guy on. So the next step is then to screw this in. And to do that, it's a bit of a tight fit. As I say, this wasn't made for 16 gauge wire, so I have to hold this with a pair of pliers while I screw this on. Tight fit, not a bad thing. Okay, that's on nice and tight. Next step, I want these wires to be the same length. And now they are. So if I had tin first, then one of them would have been longer. As it is, they are. Bring my buddy back in here again. After I strip off, and I don't need to strip off too much. I'm going to start at this. That's about the same. Get rid of garbage stuff there. Do a twist on these wires. It's not bad on these, but especially on the smaller gauges, thinner wire. If you leave that little bit of insulation on and then twist with the insulation, it makes it a whole bunch easier to twist your wire. So now we use our soft vise component. Put that one in. Soft vise component. Put this one in. Whoops. The other thing is, if you're not great at soldering, I sometimes use this little piece of wood under to catch hot molten solder. But I've been doing this for a while and I actually enjoy soldering, so I don't worry about it. So, some flux on. I need to get a better flux applicator. I think I'll get a popsicle stick. Or go to Starbucks and get one of their stir sticks. Every once in a while I go to Starbucks and I grab about a dozen of their wooden stir sticks. I find they're great for paint mixing. They're great for this kind of application. When you're doing building, they help to hold things together. All sorts of stuff. How's that for a nice roll of solder? It was 20 bucks or something, and it's 0.025 inch diameter. It's a little thicker than I'd like, actually, but it's, for the price it'll last me till I die. Let's see, get this down so I can see what I'm doing here. Heat this up. I know you're supposed to apply the solder to the opposite side of where you're working and all that stuff, but I've been using this method. I mean, you've seen the videos, you've seen how old I am, so. I learned to solder in high school, interestingly enough. And we had soldering irons. I can't remember how I think it was a gas furnace that we used to heat them. And there were these great big heavy things, so they'd retain the heat. Big to clean them with sal ammoniac and files and all sorts of other things. And yeah, well, that's extra stuff you need to... Anyway, I'm pretty happy that's gone as far in as it needs to go. Clean that off, put that down. Give that just a little bit of time. Now, while I'm doing that, grab my, wherever I put them, there they are. Make sure that these are fully open. Make sure these guys are fully open. Okay. This will be fine now. Should both be fine. So I'll put my little helper away. Take this and clean off anything. Yeah, I know, I could use alcohol and clean it off properly, but I'm not going to. Get that out of the way. Now, last step here is I want these to be twisted. So I have to do the twisting myself. The reason I want to twist it is with this gauge, if I don't do that, then they sometimes get a little caught up. The other thing I want to do with this is I want to flatten the ends where they go in. So before I do that, I want to make sure they're the right depth. Perfect. What about this guy? Just a tiny bit long. We'll cut that amount off. Yep, I can just see where, yeah, a little bit more off of the black. Now, squish these guys down so there's a flat spot on them. If you look at these pliers, you can see there's a flat edge there, so it's not serrated till they're part ways in. That's just enough to let me flatten this down just a little bit. Why do I do that? Yeah, I don't know. Maybe it gives a little bit more bite. There's more of a surface there. It's just part of what I do. Okay, so black one's going in. We'll screw that down. Around, just looking for flat surface. Okay. Well, I twisted this red when I twisted a little bit off. So I'm going to untwist it first so I can straighten it a little bit more. Then it will fit in here better with my flat surface. Okay, it's now in. Now I'll tighten this down. Now there's one thing I haven't done yet, and normally I do it before now, but while I'm twisting this time when I twist, I'm pulling evenly on the wires so one shouldn't get shorter than the other. That happened with that red one last time. Anyway, the thing that I haven't done is I haven't tested this. I don't want to just plug it in and hope the darn thing works, because if it doesn't, it'll short things out. So I need to test continuity on these wires and make sure that I haven't done something weird during all this assembly. Seeing as I had done one just prior to this, I feel pretty confident on it, but I always check anyway. I just don't want to fry up an $800 Ecos because I didn't spend an extra couple of minutes doing something. It always amazes me doing some of this stuff is like trying to do this wrap isn't the easiest thing. So there we have it. Now here's my continuity tester. It's quite simple. Here's a little battery pack. Has 2 AA batteries in it. 2 leads. And these leads are the little clip-on ones that I like. And I've soldered in a light bulb. So, because my hearing's gone a little, when I touch these together, oops, if you can, when I don't have it, you can see light on, light off, light on off, on off, on off, on off, on off. Now, the nice thing about this is I also have a little power switch here, so I can turn it off when I'm not worrying about it. Alright, so I'm going to test the outside first because I know that clips on really nice. And at the other end, that's going to be black. So okay, so black's going through. What about the other side? Nope, nothing's going on when I touch red. Now, what's a little trickier with this is I'll have to go in here on the red side, which is going to be center pole here, so that's why this is a little bit tricky. Because I need to get this guy into the red and making contact. Which it is right there, and then this needs to touch the center red, and it does. Okay, so whenever I touch the center, I get a light. I'm on the outside, all the way around, even into the outside, I get nothing, and it's just there. So now continuity tester says that I've assembled that correctly. And that can go back. So now that all my wiring's done, I'm going to clean up, and then we can go ahead and get back to Ecos.